Hello and welcome to another ClueCon Weekly. We're here in the ClueCon Weekly podcast studio, and today I'm delighted to be joined by Jiri Kuthan. How are you today, Jiri?
Hello, I'm doing fine. I hope you too.
Yes, doing well. And whereabouts are you joining us from today, Jiri?
I'm joining from Prague Czech Republic, where I'm currently being locked down with my family. Otherwise, I live in Berlin, Germany.
Okay, well, thank you very much for joining us from there. And I'm pleased that you look happy and healthy and that you're getting to be locked down with your family. There are worse places to be locked down than with one's family. That's great. Now, Jiri, we've got you along because we love having interesting people on the ClueCon Weekly podcast talking about interesting things. And you're a man of great history in the world of SIP. And of course of security as well. But in terms of getting to know you a bit for our ClueCon Weekly audience, I wonder if you can give us a little bit of a background in terms of your career history and what's led you to the point in your career that you're at now.
Yes, sure. So I think my professional history began in the past century, as a matter of fact. When Henning Schulze, one of the SIP inventors, was my professor in Berlin, and that's something which has stuck with me till now. Till today I work on SIP. Initially, we were very excited just about getting SIP going and running and making sure that the protocol works. And that took us quite some year. Actually, if you look at the full history, not just mine, the first papers relating to voice over IP began to be published in early 70s. And it has taken about one human generation that voice over IP began to make it in production. In the institute where I met Henning Schulze, we were doing the first pilots for some operators, and then I moved to MCI for some time being, and that was 99, 2000, 2001, when we began to roll out the first SIP services. And it took a few more years. It was like 2004 when the services began to be offered massively to consumers. So it took pretty much 30 years from the first scientific publication until consumers began to use the technology without actually often even noticing it. And we were very lucky that we began to work on that exactly in these years. So we were able to enjoy the satisfaction of seeing it being rolled out. So we just didn't publish papers which would end up in paper bin, but we saw our families using voice over IP in 2004. That was fantastic.
Yeah, can I just interrupt for a moment there, Jiri, and just ask you, because of you were there in those very early days, of course, H323 was also there in those early days. And was SIP like a reaction to how bad people thought H323 is, or just a competing technology? What was the relationship between the two of them in that time?
For us as technologists, it was incredibly funny time. It was a real battlefield. And I remember many conferences with heated debates, some prominent advocates like Henry Zinreich from MCI WorldCom by then speaking very blatantly of H323. And retrospectively, all of the both technologies had some pros and cons. And it was a battle on the edge. And the piece which I think moved it towards SIP was that SIP was adapted by 3GPP for use in mobile networks. That had some penalty with it. It took quite a baggage of backwards compatibility, and it introduced some things which were not technically very pleasing to the protocol design. But that was the piece where those who were not decided chose to go out with SIP, and H323 still kind of exists, but SIP is prevailing, absolutely.
But very much so. Yes, you still see H323 in some kind of proprietary video conference solutions and proprietary PBX manufacturers, but I think is pretty much on its way out. Anyway, sorry, I interrupted you, Jiri. Please go back to telling us about your career history. Very interesting.
So I think the really interesting times, that was beginning of this century, 2002, 2003, 2004, when we see the massive consumer adoption. And by that time, we came out of our research institute and we published what's known as Kamailio today. That's what created the context how I've been invited to this talk. Actually, it has been my team that has created what's known as Kamailio today. It used to be called by then SIP Express router, before it began to fork. And
sorry, another quick question. So when you were creating that in the Fraunhofer Forum days, was it created as a commercial project or product, or was it created as an open source thing at the beginning?
We were looking at both. So we had from beginning on the ambition to start a company. At the same time, we had a concern that if we start from a research institute, we will not have a fund, and just own for lack of marketing funds, we will end up in obscurity. So we combined a couple of purposes in that we released the software open source. First of all, we started at a research institute, so it was quite obligatory to publish results of our work. And at the same time, we hope to become known and famous by doing so. And in the expectation, it would create a stepping stone for starting a company.
Great. Okay. Yes. Please continue.
Which we did. That company was later acquired by Tekelec, which became part of Oracle over years. And we continued to move along with SIP. And when basic SIP was running, also thanks to Kamailio, the next challenges were making the operation perfect. And the step one was doing more on the monitoring side, and the next step was security. And already at that time, we began to be worried that it has been neglected in the beginning, which is very often the case with technologies. You just want to make it work and run and see the results, and you're not initially concerned about security at all, or very often. So we began to care about it retrospectively, and by then the common approach was introducing SIP-aware firewalls. And because the traditional firewall vendors were not entirely fit to deal with the complexities of SIP, something called session border controllers have emerged. That was a market answer to the lacking support for security in the protocol standard and also in the industry. So SBCs have emerged, and I think they have been quite good answer to security problems for the time being. And over time, however, I think it began to be static, as too static for the way attacks are being operated today. So I think we are now in the age when SBCs are alone not sufficient answer again, and we need to be faster and deal with more massive and scaling attacks than SBCs used to deal with.
Right.
So that's how we ended from the history in the present.
Yes.
That's I think the 2020 situation. Large scale, massive attacks from millions of IP addresses and causing quite some substantial damage to voice over IP users.
Right. Okay. Well, thank you for explaining that. So we've kind of covered your career history, and it seems that it's been intertwined with SIP, and then in the later part, intertwined with SIP security. I wonder if you could take us back to those early days, from the no security days to when you first started noticing attacks, and whether it was those attacks that prompted the discussion of security, or whether you were thinking about security before the first attacks that you saw came in, and what was the nature of those early attacks?
So initially we thought it could be a problem, but it just at least it didn't appear on our own to-do lists. There were so many other exciting things to be worried about that even if we knew this would come, we didn't care much either. Basically speaking, really technically, the first challenges which we did on day one was making sure that the users can authenticate, and which by then protocol-wise was done by HTTP digest authentication in SIP, and that we have a sufficient number of ways to blacklist evil users and to whitelist good users. And that was good enough for quite some time. But we knew it would be more difficult, and we didn't. And then there were even companies that were coming up with the solutions for problems which didn't exist. So initially, everybody was just guessing, and the very reason why is that SIP was totally unknown, and the attackers began to discover it. So one could have made projections what it could be, but no one really knew in say 2005, and. So we made some projections. A lot of the trivial attacks were countered by using proper authentication and proper blacklisting. But for example, what was not anticipated was the massive scale at which it was coming. And we had a very basic idea that when that scale appears, performance matters. And I would say that's still today a very, very effective way. So there were vendors doing all kind of exciting applications written in Java and scripting languages. I have to submit to you that when the first attacks appeared, their servers disappeared. And that was the reason why we were very focused on performance from the early days on. And we did achieve thousands of calls per second by then, capacity which would, with SIP Express router capacity, that would be able to power up all of the San Francisco area. And it turned out to be very effective against security attacks because we survived those. So performance was a kind of generic but still very good answer to that in the early days. And we saw that, I think it's like 10 years ago when botnet attacks began. They have been orchestrated, SIP attacks have been orchestrated in the dimension of 3 million hosts attacking a site. That's
Amazing.
Quite massive. And you're not going to manage that with a comma-separated value managed blacklist.
Yeah, that's incredible. And what is the relationship, or maybe the split, between attacks that are centered around toll fraud and attacks that are centered around denial of service or other nefarious objectives?
I think these two are diverse ones. There are a lot of others which are almost esoterical or used by PhDs to explain more reasons why their PhD thesis is good. But the real ones are those you mentioned, and that's DOS and which are irritating, and fraud. And I would say both are irritating, but fraud causes a little bit more of a very immediate pain. And a typical scenario is even if you're a small company, you don't have to be an operator. You've got a small PBX. Often, say you're a Asterix guy, you've got your Asterix, for example. You leave your installation with some security gaps, and you return from weekend, and you find out that the telecom bill is, say, 10,000 euro. That's about the range which we have heard reporting from customers and users. So that's something which is, you may be disturbed by denial of service attacks. It can be irritating. You may have scheduled calls, but very often you have some alternatives. You can use some web facilities. You can use cell phones. But if your PBX is hacked, it's gonna be expensive.
Yes, indeed. And that situation that you described, coming back over after the weekend and finding yourself with a very big telecoms bill, sadly not uncommon. Lots of people have suffered that to a greater or lesser extent. So just thinking of these attacks, how have these kind of things evolved from the time that you first saw them to where we are today? You've talked about the scale and the power that's brought to bear on them, but in terms of the nature of attacks, from probably fairly unsophisticated password hacks and things like that, how have they evolved over time?
I wouldn't say that sophistication has increased. I would say sophistication has remained quite simple, and there is a good reason for that. It's today much easier and effective to increase your attack gains by increasing the attack size. That's way easier than increasing the attack complexity. You can spend 2 years on creating a super SIP virus, but it doesn't possibly get you anything. But you can go to a botnet, and if you've got a simple tool which does what you need to do, you achieve very quickly the same goal by larger scale. So I think there is a simple explanation why we don't see increase in sophistication. And most attacks, they are as simple as a couple of scans, sometimes distributed, sometimes not. You see the first packets coming in. They very often even identify themselves as attacks because the originators don't bother to concern the attack signature. So you see very often packets coming from a SIP-friendly scanner, to name the most popular one. Sometimes they do masquerade as Cisco gateway. Sometimes they don't. And if they find a responsive SIP server, what typically follows a password guessing attack. And guess what? A speed you can see is 100, 150 attempts per second. And with that speed, you can find a Oxford Dictionary password within an hour. So if you've got sufficient bandwidth, in 1 hour, you find a password. That's way easier than trying to break cryptographic protocol protection. That would take you a year.
Right. So brute force is the order of the day and the power of the attack. But when an average PBX user, whether that's on something like Free Switch or Asterisk, falls subject to a very high-powered attack, what can they do about it? Can the current technologies defend like kamailio? Within the programming capabilities, if you like, of the average PBX user or PBX deployer, I should say.
There's certainly a lot of measures you can do today. It depends on largely on how open you want your system to be. There are some users who are using still TDM for interconnecting to the outside network. For them, it's simple. You've got your PBX, you run your services in your private network, and you interconnect using TDM, and then most of the time you're safe against SIP-specific attacks. If you want to open up, which is happening as TDM is being replaced in many countries, you need to be a little bit more careful. In the most common scenario, you still connect to a trunking provider. So it's kind of TDM on IP. And then you can have some static policies which do a pretty good job. The most irritating case is when you want to open up for a variety of reasons. And then you really must be careful about your policies. Now, we know what it takes to configure Kamailio. And even though I have written some of the code, when I look at the kamailio configuration and I'm concerned with security, I read very slowly and diligently. It's complicated. So you need to make your SIP policy right, and there are some things which sometimes you don't even cannot make right. As an example, if you really want to be sure no one, not a third party, sends requests on your behalf, you've got to authenticate every request. I'll tell you that 3 out of 5 SIP telephones will not be able to authenticate their buy requests. They authenticate just invites and registers, period. So you've got to have some knowledge of SIP and knowledge of the SIP server to get it right, and balance between how open you are and how secure you are. And you need to do even the same on the IP level. So some users are using to some reasonable level of satisfaction. They are using fail to ban. It has some limitations too. The basic one is that there is not that always you get surprised by new logs which you didn't think of that reveal that something's going wrong. So it's not entirely waterproof, and you've got to be careful what all kind of traffic you block. Still, by that, if you know how to manage the Linux software and your routers, I would say you're 99% safe. I would say the most troubling part of that is you've got to have the skill set.
Yes, very much so. In fact, we have interviewed Fred Posner on here as well about API ban. And of course, API ban is a preemptive thing that uses honeypots in order to build up a list of bad or known to be bad actor IP addresses, and then preemptively stop them with firewall rules. And as you just mentioned, fail to ban is there based on the logs, and again, notwithstanding the fact that you might see some unusual logs, but between those two, I think it sounds or it appears that you can keep most of the bad guys out, but it's not 100% watertight, and so there's still work to be done. Now, in your career history over more recent years, Jiri, you've been involved in session border controllers. Can you tell us a little bit about how those have changed from when they first came along as a concept to what would happen when people are buying a session border controller today?
That was a funny history and a battlefield too, because initially the SBC proponents, like it happens very often with technology, came with solution. SBC solved this and that, and you can make also French fries with that. And the overwhelming offering of what an SBC can do and save the whales was kind of irritating. And initially, in the early day of chaos, there were some good reasons for them to emerge, and there were some bad reasons. But I think what made them really exist was that initially the SIP design didn't consider NATs. That was some of the architectural legacy in the Internet Engineering Task Force. People were excited about the prospects of IPv6 and removing NATs forever. I think that was quite a naive contemplation. By that time, NATs were widespread already. And the illusion that as much as they have very many negative side effects to the internet architecture, they are not going to go. And the illusion that they would go was just naive. And the SIP protocol didn't account for net traversal by that time. And that's exactly what the SBCs did. And it was a compelling problem. And when the standard body was not able to solve it, the market did. And it solved it using the SBCs. Basically, what they did was they relayed media to a centralized point on the internet, and so it reduced peer-to-peer media traffic into 2 pairs of client-server traffic, something NATs are able to deal with, and as a result, people were able to make phone calls even from behind NATs, which by then was not really possible with SIP. So that's how SBC emerged. And then the vendors, once they found there was a real opportunity in the field, they began to add features. But it started with NAT, then more security policing came in, and also as there were in the early ages, there were a lot of implementation errors. The SBCs began to adjust SIP protocol in a way that devices from different manufacturers can interoperate with each other. So mediation emerged, and we ended up with net traversal, security, and mediation as the key arguments. And that has been good for quite some years. On the downside, what has been problematic, and that remains, that's an architecture shortcoming. It creates a new single point of failure and a bottleneck too. It's a very centralized approach, so that needs to be accounted for when deploying the technology. But it has been solving real problems, and one just has to live with some of the downsides it brings in.
Okay, all right. Well, thank you. And you're talking about routers and NATs and things. You've prompted a question in my mind, and that's around the SIP ALG, the application layer gateway, which most of us who have been involved in implementing practical SIP systems have come across at one time or another. I wonder whether you might talk a little bit about the concept of the ALG, the application layer gateway, and what it's meant to do, and why it ends up kind of ruining SIP for practical purposes most of the time.
Okay, so ALG, application layer gateway, it's a solution to the problem of net traversal, and maybe it's worth reiterating what that is. And the net traversal is a problem created by SIP protocol design, which advertises devices' IP addresses in the protocol. The problem is that when different devices are in different IP networks, which are not interconnected with each other. So typically, if you're behind your home router, you're behind a NAT. Your local IP addresses in RFC 1918 format is something like 192.168.0 something. And that's not routable from outside internet. And your SIP phone sends this address in its payload and says, send the voice here to me. And the address is odd. It cannot be routed. So quick solution to that which emerged, and I think the first came from a 3Com intern back in, I would say, 2002. I have unfortunately forgotten the guy's name, but he was an intern at 3Com, and he hacked Linux kernel to look at SIP traffic, which is going through a Linux router, and fix the private IP addresses and replace them with the router's public IP address. And that worked, and it helped the early adapters. Unfortunately, there is an inherent problem with that, and that is SIP protocol is complicated. And that means that if you hack the kernel and implements all of the SIP wells and bistles, you need to make sure that you implement all of the SIP headers, that you look at all of the SIP extensions, because many of them can carry IP addresses. And very often what happens is that by changing the signaling, you're going to break it. Typical situation is you buy a new router, deploy it at home, and you're wondering why you cannot make phone calls anymore. That's because it's using some Linux ALG with outdated SIP support. It perhaps likes some SIP traffic, but it may not like the SIP traffic coming from your specific SIP telephone. It breaks it, and as an end result, you're not going to make a single SIP phone call. And that happens. So I would say today's advice of the day is, if you've got such ALG, I would recommend you to turn it off to make sure that the SIP is going to get over. It's ironic. It's there to help SIP traversal, but typically it does not.
Yes, good advice. And of course, in the earlier days, that would have meant learning the router's particular language and maybe using a telnet session to go in under the hood and issue special commands. But these days, they do tend to show up in the GUI a bit more. Well, Jiri, we're very grateful for you to come in and share some of your experience and expertise. And as we come to a close, I wanted to ask your opinion about the future of security in the world of SIP. That's something, or the area of security is something you spent a large part of your career dealing with. What do you see coming our way in the years to come?
Well, I think we have to answer the attack size as it's coming on us. So it's elusive that we would be able to deal with orchestrated attacks by isolated approaches. So the attack size and magnitude must be answered somehow. And I think that's the basic problem statement. Now, of course, I hope I'm in the field which is trying to get it right. And I think a proper solution to that is use actually the same techniques as the attackers do use. Have massive answer to, and that includes massive collection of intelligence data and operating real time as the attackers do. So I think a simple advice is bet on technologies that have very good intelligence by gathering a lot of data, and that have analytics that looks at what's wrong and block it real time before it's late. Just be faster than the attacker is.
Yeah, now just thinking about the huge scale of some of the attacks, the processing power needed to deal with those attacks is really beyond the scope of an individual PBX or an individual SIP implementation of some size, of a normal size. And so, do you see SIP security as a service coming our way in terms of people providing cloud-based services that have got all the horsepower to determine dissolve these attacks and then passing legitimate traffic through to the smaller PBX implementations?
So I think some way of cloud, which is fashionable year of the decade, is certainly the answer. I think there are two ways. One of them is that you concentrate the intelligence in the cloud and run some local policies. And I think that's going to be attractive for many who do not wish to route all of their traffic through cloud providers. That needs to be a little bit leveled. I think blocking some of the traffic when it hits your telephone is quite late. So it depends on the scale of the attack where you block it. For some of them, it's good enough that you block it at the PBX, Kamailio, free PBX level. For some of them, you better go to edge routers. And for some really massive attacks, you have to go even deeper in the network. So it's this differentiation between the size of attack and where you place the defense. And I think a good sophisticated answer is able to discriminate that and place it at the proper place. I'll tell you an example. We have seen massive attacks from an IP address, and they were really massive, identified by a single URI. A quick answer to that would have been block the IP. That was not good enough, though. Why? Because we find out that it's an ISP who is hiding all of his users behind a single IP address. So the ISP was using a carrier-grade NAT, and blocking an IP address would have blocked many other innocent users. So the proper answer is use centralized cloud intelligence and have the algorithms choose wisely at which level to block, so that you're not blocking too many and you're not blocking too few.
Wise words, and perhaps easier to say than do in some circumstances, but certainly needs to be done.
Yeah, well, we try to design it this way at Intuitive Labs, and I think chances stand good based on the measurements that is the right approach. But there are alternative technologies too that try to do hosting and filtering all of the traffic, and that may be a solid answer too.
Right, and the approach you're describing, is that what you're implementing in the current company that you work in, Jiri?
Yes, that's what we are focusing on. We have been traditionally concerned with many security sensitive customers, and for many of them, routing all of the traffic through someone who will clean that is a too scary prospect. So they want to retain the traffic and filter on their own, but they do not want to give up on the centralized nature of the filtering intelligence.
Great. Okay. Well, thanks for sharing that. And people can see your email address just below you, jiri@intuitivelabs.com. We're coming towards the end now, but just one question that I like to ask when we're near the end of an interview, and that is there anything else you would like to mention to the ClueCon weekly audience before we close?
Well, keep using SIP. It's a good technology. Don't be scared by security. I think that's a very important thing. We try to explain what's going on in detail, not to scare people. So just look at the facts and be sure that the attacks can be dealt with.
Right. Okay. Well, thank you so much for coming in and sharing your knowledge and experience with us, and of course going back in time and giving us some insights into how it was in the world of SIP in those early days. We're very grateful for you doing that, Jiri, and I hope I get to see you in real life at some stage, maybe at an in-person kamailio world when we're kind of back to normal.
That would please me, and thank you for being a kind host to me.
All right. You're very welcome. Thank you. Bye for now.
Bye-bye.